Good afternoon. Today we're going to talk about perfect square quadratics and a process that's called completing the square, which we will use to solve more complex quadratic equations. But the way we get a quadratic equation is by multiplying two binomials together, something like x plus 7 times x plus 3. And again, we FOIL, right, to get our terms. So x times x is x squared, x times 3 is 3x, then the last times the first is 7x, 7 times 3 is 21, and I'm going really fast because this should just be review. X squared, the two middle terms combined, gives me a 10x plus 21, which gives us this quadratic. Quadratic has an x squared term. A lot of times you'll have a middle term of a single x term, no exponent on it, and then a constant. Well, a perfect square quadratic is not multiplying two binomials together that are different. A perfect square quadratic is like if I took x plus 7 and I squared it, squaring it. This is called a perfect square quadratic. And let's FOIL that together. In other words, remember, we got to take an x plus 7 times an x plus 7. The thing students forget is they want to just square the x and square the 7 and say it's x squared plus 49. That's incorrect. We got to do first times first. That's x squared. First times last, that's a 7x. Last times first, there's another 7x. And last times last, that's a 49. Now again, we have these two middle terms that combine. That gives us x squared plus 14x plus 49. So this quadratic is considered a perfect square because when you factor it, it factors into a single binomial that we're squaring. Now, here's the interesting thing to realize is that this last number is the 7 squared. So we do absolutely have a 49. The first term is our x squared, so we'd absolutely have an x squared. But then we have a middle term. That middle term is the 7 times the x doubled. That's simply all it is. It's doubled. So again, if I was to give you something like, let's say, x plus 5 squared, what you could realize is that I'm going to have that first times the first, which is the x squared. The first times the last, which will be a 5x, the last times the first, which will be another 5x, which together that gives me a 10x, and then the 5 times the 5 gives me the 25. So if you'll notice, this middle term is just twice the x times the 5, and then the first term is the x squared, and the last term is the 5 squared. Well, knowing that will help us to what's called complete the square. And what I mean for that is this. Let's say that I gave you not the binomial squared, but I just said I gave you x squared plus 8x plus some number, and I wanted this last number here to be the right number to make this a perfect square. In other words, to make it some simple binomial squared. What would this number have to be? Well, the way I like to do it is I like to remember that we get the middle number by doubling this number. So if I get this middle number by doubling this number would have to be a 4. Then if I square the 4, this number here would have to be 16. So this last term here is always half this b value, and then we square it. Because remember, a quadratic is written in the form of ax squared plus bx plus c. I did capitals, but they don't need to be capitals. I take that middle term, take half of it, which is 4, I square that, and it gives me 16. That allows me to write a quadratic that is considered a perfect square. Now, let's talk about how minus signs fit in. In other words, if I gave you the quadratic x squared minus, let's do 14x, and then some number here, would it ever be a minus or will it always be a plus? And I want you to realize it's always going to be plus. And the reason is is, if it helps, let's go over here and write this out. And remember that this term here is always half this term. Now this term is a negative 14. So I am going to do a negative 7 because half of negative 14 is negative 7. Then I'm going to take the negative 7 and I'm going to square it. Negative 7 times negative 7 is always going to be a plus 49. And I've completed the square. I've written the quadratic that's a perfect square. So now you will get fractions or decimals. So again, if I had the x squared minus, I don't know, 7x plus some value. And again, it's always going to be plus. What would this value be in order to make this quadratic a perfect square? Well, if you need to, write out this little binomial that we're squaring, and remember that this number here is always half this number. And keep it as a fraction. It's so much simpler. I'm going to write it as a minus 7 halves, not 3.5. You could do 3.5, but then you'd have to square 3.5. I don't know what 3.5 times 3.5 is, but I can square 7 and I can square 2, which means I'm going to get a 49 over 4 as that last term. And again, a negative 7 halves times a negative 7 halves is a 49 fourths that's positive. So again, if that middle term is an odd number, you will get a fraction, which is perfectly fine. You could even actually have a fraction. And what I mean by that is this. Let's give you x squared plus 1/2 x plus some number. What is going to make this a perfect square? Well, again, I'm going to right off to the left, write this x plus something squared. And what number goes here that's half of 1/2? Well, what's half of 1/2? Half of 1/2 is 1/4. And it'll be positive because it was a positive 1/2. Half of positive 1/2 is 1/4. And then I square 1/4. 1 times 1 is 1. 4 times 4 is 16. And I get a 1/16 as that third term in my perfect square. So hopefully this helps you be able to do this assignment. If you have any questions, please bring them to class. But just remember, always take half of this middle term and square that number, and that's your third or missing term to make the quadratic a perfect square.